Threaded hardware can be something of a pain in the butt, but anytime we're working on a car, we're going to have to deal with it. So regardless of whether it's a pain in the butt or not, we have to know something about it. So when we talk about threaded hardware, what we're really saying is things like bolts and oh, here's a nut. All right. So these are all examples of threaded hardware. It has threads on it. Okay. And maybe this bolt would go through two parts to hold two parts together, or maybe a nut goes on the back side of the bolt and the parts are in the middle to hold things together that way, and just however it works. But there's some stuff that we really have to pay attention to, because if we don't, we're going to screw things up. One of the biggest issues that you're going to run into when working on cars is going to be removing stuff like this and replacing things like this. And in order to replace it, you have to know exactly what you're working with, because this looks an awful lot like that, which looks something like that, looks something like that, okay? But all of those were very different. So let's start by considering our two thread types, our two hardware types, and their measurement. So measurements can be done in either standard or metric. We're going to start with standard. Now, standard hardware is measured in inches, and it's measured in fractional inches. So this guy right here is 5/16 of an inch. When we're talking about 5/16, we're talking about the diameter across the threads. We are not talking about the head. We don't really consider the head size much when we're talking about the actual size of the fastener. So this is 5/16 of an inch from here to here, okay? And so if I were to actually measure that, I'm going to come up with the measure of 5/16. All right, that's the first part. The second part we talk about is going to be the length. And the length is not the total length of the bolt from here to here. It is the length of the shank. So if I've got this fastener here and I look at that, this is the actual length, okay? Not that head to here. So when you're measuring to replace, you're going to go along the shank and the threads for your length. You're going to look at what's known as grade. Grade is how hard the bolt is. So if we've got a suspension component, it might have a completely different grade than a component in a engine. All right. The suspension component might actually be softer, so that if you hit a curb or something like that, the bolt bends but doesn't break. Where an engine part might be harder, because we want to make sure that we maintain the clamping force between parts. So for standard hardware, we look for lines. You can see right here that I've got 3 lines on this bolt. And this one, I've got 6 lines. On this one, I've got 4 lines. Each one of those is a different hardness. That hardness is going to be the number of lines plus 2. So this is actually a grade 6. This is grade 8. This is grade 5. 3 plus 2, 6 plus 2, 4 plus 2. The bigger the number, the harder the bolt. That's important. Now, the next thing we're going to look at, and this is the one that really screws people up, is the pitch of the threads. And if we think of pitch as an angle, which is exactly what it is, this starts to make a little more sense. All right. So in standard hardware, we're looking at the number of threads per inch. Okay. So we would actually count 1, 2, 3, 4, 5, so on up the line. And if we're looking at our threads and we measure them or count them, if you really want to, your eyes are going to cross, I'll tell you that. All right. Then what we're looking at is 2 different thread types. we've got national coarse and national fine. National coarse, or NC, has fewer threads per inch. National fine, or NF, has more threads per inch. So the more threads it has, the steeper the angle is. The fewer threads it has, the shallower the angle is. And that's where the term pitch is coming through. Okay, so at any rate, we've got right here, this is a national coarse bolt. It is 5/16 of an inch diameter, 18 threads per inch. Right here, this is a grade 5 national fine bolt. And if you look at that, you could really see the difference in the pitch of the threads. These are very close together. There's a whole bunch of them over a 1-inch area versus this. So if you try to put your national coarse nut on here, no problem. But if you were to try to put that national coarse nut on here, it might thread on maybe one turn and stop. And that's probably the single biggest key to hardware. If it only turns in 1 or 2 turns and then stops, and you're turning by hand, you better figure out why it stops before you put a wrench or a socket or anything else like that on it. Because if you force this in, all you're going to do is screw stuff up. I mean, you're really going to screw stuff up, and then life's going to be bad for you for a little while you fix your stupid mistake. All right, so there is a whole bunch of stuff on standard, right? Let's look at metric. Now, here's a funny thing about metric. In this country, the United States, there's a whole bunch of people who are like, metric sucks, standard's the best, it's what we've always used. Okay, metric is easier, period. Our units are in millimeters. Our grade, the hardness, is a number. There's no adding to this, and it's very easy to see. 8.8 and 10.9 are common grades for metric hardware. That 8.8, like that, is actually stamped right onto the head of the bolt. Okay, so that's really nice. That's very handy. And that means that this is softer than a grade 10.9 bolt would be. 8.8, super common. You see it all the time. So the grade hardness is not adding, subtracting lines. It's simply a number. Thread pitch is really easy. It's the distance between threads. That's all it is. So I've got 1 thread, 2 threads, and they have, on this case, 1.5 millimeter between them. So that means that this is a 1.5 pitch bolt. The diameter is just like on the standard side, it's this right here across the threaded portion. This is a 10 millimeter bolt. So that means that this is a M for metric 10 1.5 bolt. Very simple. Length is going to be measured in millimeters, and it's going to be just like on standard from the bottom of the head to the end of the shank and threaded portion. Very simple. This is so much simpler to deal with that I actually had a bunch of extra time, so I drew a stupid picture of a longboarder getting ready to hit a deer. All right, so that's really all there is to say about metric. Now, the easiest way to tell metric from standard is almost always going to be to look at the head of the bolt. Does it have lines like this? It's hard to see, but there's 3 lines there. Does it have a number like that? Pretty easy to see that number. Let's find a bolt here that has better lines. All right. Standard, metric, standard, metric, standard, metric, standard, metric. We don't have to guess when we see lines and we see numbers. If you've got a metric number here, you know you're dealing with metric hardware. Don't try and put a standard bolt back into that stuff. That would be stupid. It really would be. If I've got standard hardware, don't try to stick metric back in there. Very dumb. All right. What if we do this? This has no numbers, has no markings. We don't know what this is. In that case, I can use a tool, something like this, where I can kind of figure out what it is by simply laying these threads against it to see, do any of them line up? Or maybe I start trying to thread that in. Well, what do you know? That seems to thread in pretty good, but it's a little loose. So it's not actually the right size. I can go like this, and that looks like it lays in there pretty good, but it rocks a little bit. Well, that is an M10-15 thread. This bolt, that's probably the closest we're going to get, doesn't seem to be M10-15. So let's come over here and let's take a look at this. This right here is 3/8-24. I throw the threads against there and they clearly don't match up. So if I go like that, and I've got now, look at that, matches up. Look at that. Threads in nice, not really loose, pretty tight. So this is my actual size, 3/8-16. So we can use tools like this. We can use known bolts. This is 3/8-16. This is 3/8-24, no good. Metric, no good. So we could start to use other bolts that we know the size of to also identify. But if you see lines, you know it's standard. You see numbers, you know it's metric. That was not numbered. That one's numbered. Whee! Okay. Now, the final part of all this is nuts. We still have nuts, and nuts are also going to be in metric and standard. You don't want to try to put metric nuts on standard bolts. Don't mix your nuts up. All right? You want to make sure that you don't screw anything up. And I'm going to go through this real fast, so we're just going to lay this down, and I'm going to take a look at all of this stuff. I have a variety of different nuts that I can use. This right here is a nut with a big flat washer built into it. That's known as a flange nut. This right here is a nut that has some sharp serrations on it. That's for locking the nut in place. So that's a serrated nut. This right here is just a nut. It's just standard. Maybe it's metric, maybe it's not. I don't know. Right here, this is known as prevailing torque. And you could see, if you look closely at that the opening of that nut is not quite round. So that locks down on the fastener when we're putting the fastener through it. This one right here, you can see that white plastic in the middle, that's a nylock or nylon locking nut. It also keeps the nut from backing off. So this one, serrated, prevailing torque, and nylock are all lock nuts, and they hold the nut from locking off. Flange nut like that washer that's built in is designed to help spread the load of the torque of the nut and bolt. This is an acorn nut, and these do show up from time to time, mostly in lug nuts. So there's our different nuts. Right here, let's say that I had a nut that was like this, standard, no way to lock it down, but I wanted to lock it. This is what's known as a lock washer or a split washer. And when I tighten the nut down against that, it forces that split to kind of dig in a little bit and keep it from backing up. Right here, I've got just a standard flat washer, and that standard flat washer would just take the place of this flange nut. So it forces the load out over a greater area. Incidentally, flange nuts also come in flange bolts. So it's got that big head on it again to spread the force of the torque across a larger area. Final thing We can have bolts like this that have a shoulder on them. Those are very specific to hold things together but allow movement. This right here is what's known as a machine screw, but it actually has, just like a bolt, the same type of threads. Also a machine screw, little guy, kind of cute, has both a screwdriver slot and a hex for driving with a socket. So as you can see, there's a whole bunch of different hardware that you may have to deal with. And there's a whole bunch of things to think about. Having a tool like this is nice for helping us identify what we're working with if we don't know. But some common sense will go an awful long way to helping us out as well. Oh boy, nuts and bolts. Definitely one of those deals that just, I mean, they're gonna be a part of your life if you're gonna work on cars. So learn them, get used to them.